Welcome to the GT350 Garage. My name is Walter, and this is now part 5 of my 289 Ford engine build series for my 66 Shelby GT350. And in this video, we're going to kind of hover around camshaft and timing chain installation details. So I'm going to install the camshaft in this video, but I'm also going to install the timing chain with the crankshaft already in the engine. And I'm going to show you some of the details that you have to address when you're putting a timing chain on a small block Ford. There's a bunch of different dowel pin lengths. There's different upper gears. There's different fuel pump eccentrics. And so I'm going to cover the information on how they mix and match, and don't mix and match rather, so that you can make an informed assembly decision when you're putting your engine together. Because let's face it, you don't want to put the wrong parts together and have all hell break loose on your build. It's just not an ideal situation. And I can show you timing cover. I have a timing cover that the fuel pump eccentric walked into the front timing cover just because it wasn't assembled correctly. So if we're going to do this, I think this is a topic that's worth discussing, and so that's where I'm headed with this. Now I want to thank the now 7,000 plus subscribers that have joined my channel. I'm astonished by the number of subscribers, genuinely. I also want to thank everybody that's watching the videos. You guys are awesome. I appreciate the views. I appreciate the thumbs up and the likes, and I most definitely appreciate when you guys share the videos, because that helps get the video content out there to people who need it and can use it. So the final thing is, if you have any questions or comments regarding what's in this video, definitely drop a comment or shoot me an email to the gt350garage@gmail.com, and I'll do my best to answer it for you. So with that, let's get started and cover camshaft installation in a small block Ford. All right, let's talk about camshaft dowel pins for a small block Ford. And this will actually affect more than small block Fords. It's going to affect most Fords, in fact. We have a couple of considerations with these dowel pins that need to be taken into account. And those considerations are based off of the fuel pump eccentric that you're going to run. This is a one-piece eccentric, and it's a solid, thick steel piece. Now, the one-piece eccentric needs a specific cam gear. In this particular case, we need a cam gear with a flat face. And so this should line up and bolt on flat, and you're good. Now, if you have a timing gear with an offset face or a step, chances are it is designed for a two-piece fuel pump eccentric. If you try and run a one-piece on a two-piece, it will push this too far forward and it can hit the timing cover on some timing covers. If you try and run a two-piece on this, because of the eccentric value of it, what'll happen is you can see behind here that it's not centered, right? Well, the two-piece has a hub that is similar to this. It's stamped, and it has a tab that's bent out of the back. That tab actually goes into the dowel pin hole. The outer ring spins or floats on the inner hub of the two-piece eccentric. That particular combination is fine. It doesn't have any serious issues. It works. This is a little more robust, a little more reliable. But if you're going to run a two-piece, no big deal. Just make sure you're using the correct gear. This is a Ford Racing B302 steel gear, and as a result, it requires a one-piece or no eccentric at all. The two-piece, you'd have to run a different timing set, period. There's no arguing it. And at that point, it makes it difficult. If you're looking for a 9-keyway lower, you have to be very specific in ordering the correct timing set to do this. Now, This is where it gets a little more interesting. The nose of the camshaft is the same regardless. All of the cams use the same nose. And the thrust plate, which is going to bolt on in between and hold the cam in place, goes between the gear and the camshaft. Let me weasel this together here. Set that down. Just tap that into place. It's kind of snug. This should spin freely in here, and you should have a little bit of movement, a few thousandths actually. And we can measure this, even though it's essentially, it's going to be fine because we can feel it has clearance. But there's a 10. Let's see if we can put a 14 in there. Cannot put a 14 in there. A 12 is snug. So 10, 11 is a little snug. Basically, you're looking for roughly 10 thousandths clearance. 8 to 10 is going to be fine. As long as the camshaft's not moving around a whole lot, this way, you won't have any issues with your distributor gear or your timing. If there's extra play in here, this gear will move related to your distributor, and that will change your timing. So the last thing you want is this gear walking back and forth, changing your ignition timing. Now, on the front of the gear, this pin, if you're not going to run a fuel pump eccentric at all, has to be flush so that when you put the washer for your cam bolt on, the washer fits flush with the surface. If the washer doesn't fit flush and your cam pin sticks out, and you can see I've actually polished this one because it was really close and I didn't want to modify a washer. If the pin sticks out because you have the long pin and you're using the thick washer, which is not what you're going to get from ARP. ARP's washer is paper thin compared. Not that there's anything wrong with this washer. It's absolutely fine. It'll do the job great. But if you're using an OEM style, basically spacer washer, what we've done in the past is we'll notch the washer so that the washer sits over the pin and the pin actually is held in by the washer by about that much. And it's fine. It works. You can just notch it. You can notch it with a bench grinder. It doesn't have to be fancy, and it will work. It will not affect the washer's ability to retain the cam gear, and you don't have to worry about anything there. Now, so let's get this up close to the camera. If you were running a two-piece, this has to be recessed about 200 thousandths, maybe 250 thousandths. That's a quarter of an inch, right? So for you metric folks, minimum of 4 millimeters, but basically 6 millimeters, that pin needs to be recessed. Now, the pin that's in this cam is this length pin. This is the pin for a two-piece eccentric. And if we put them on the same plane, and hold them so that you can see that there's not much of a difference. It's maybe maybe 185 thousandths, so roughly 3/16 of an inch. And that just happens to be, if we line these two pins up, well, let's do it this way. If we drop that pin in there and we put that pin on top, it just happens to be about the thickness of the one-piece eccentric. So this is kind of important information if you're building a small block Ford. Make sure you're using the long pin if you're using a one-piece eccentric. If you do not use the long pin, your one-piece eccentric will basically try and take the cam bolt loose, and all hell's going to break loose in your engine. At that point, you risk shearing the pin that's in the gear, and you risk having this eccentric come loose. Your fuel pump will stop working, and this can actually run into the timing cover, and that's undesirable. So anyways, that is a prep work on small block Ford camshaft dowel pins, and hopefully that makes sense. Hopefully that gives you enough information that you're prepared in the event that you're starting a build or in the middle of a build and you're not sure which dowel pin to use. That will dig you out of the hole if you're not sure. Now, one very, very important word of advice. These things are not easy to take apart. So I'm using a dead blow hammer, tapping gently. You can hear it coming loose. Okay, now once it comes apart, that's the easy part. Here's the part that's not. Once you put this pin in, you're pot committed. You will not get this pin out. This pin is going to press fit in. This is a Comp Cams cam core, and I'm going to tell you right now, that pin isn't coming out of there unless you drill it out. That's the only way you're going to remove that pin. I have actually tried to remove this pin from this camshaft, and I decided that I was going to turn lemons into lemonade, and I am removing the fuel pump eccentric from the front of the engine, and I'm going to run an electric fuel pump. It was the final convincing that I needed to run an electric pump, if you will. So that's that. Now, the other thing is cam bolts. Ford uses a good quality cam bolt from the factory. Okay, and this is an OEM bolt. This is an ARP bolt. ARP uses a slightly bigger head. The underside of the head on the ARP bolt has essentially a washer surface, as does the OEM Ford bolt. I don't know if you can quite see it. There you can see it. Now, if we compare, you can see that the ARP bolt is going to go further into the camshaft. Make sure, and I mean this, make sure that this bolt does not bottom out in your camshaft, torque to spec, and this washer moves. If it does, you have a problem. So that is one very small, insignificant little detail to a lot of people, but it is a matter of almost 1/8 of an inch, and 1/8 of an inch is a lot when you're talking about thread depth. So take care, use caution, make sure that if you're going to use the dowel, because that dowel is going to go into the camshaft about that far. Make sure that you use the long dowel if you're using a one-piece eccentric. If you're using no eccentric, you're going to use a medium length dowel. And if you're going to use a two-piece eccentric, you need to use a short dowel. And so hopefully that that keeps you square and keeps you out of trouble. It's time to start putting this thing together, and we're going to install the camshaft first because the block is empty, and that means we can get it in here without doing any damage to our engine bearings. Now, I told you I don't like this runny stuff when I did my cam video. There are a few times that I find it useful. One of them is cam bearings. It is easier to assemble the engine the way I'm doing it here. And this gives me the ability to get the bearing lube into the camshafts by putting it where I want it. And so we're going to get a little bit of bearing lube in every journal. Hopefully not the cylinders, because then I have to wipe it out. Number 2 cam bearing's easier because there's more distance between these 2 main caps than there is between the rest of these. And then number 1, of course, is a piece of cake. Now, to install the cam, just put the cam gear on it. Okay? And we're going to slide the camshaft in. And yes, I know I have not put any bearing lube on the cam yet. You're going to see how I do it. So just work this through. Okay, and we're going to set it gently right there. And now, with all of our journals exposed, we're going to put assembly lube on the journals. And this way we know we've got assembly lube on everything. And this stuff will stay just fine on the cam. And then our final step is grab it with both hands by the gear, slide it into place, and rotate it around so that cam lube is evenly distributed. Now, cam lube's kind of sticky, so that's why we've got a little bit of drag on here. That's the cam lube. But this camshaft is turning nice and smoothly. Okay. All right, so we grab 2 pry bars. We put the pry bars behind the cam gear, and we use the cam gear, or the pry bars rather, to work the cam gear off the nose of the cam. And set our cam gear aside. So it's time to install the cam thrust plate. Now, this is a Ford Racing steel cam thrust plate. It's identical to the factory cast thrust plates. Has the oiling groove. Everything is just the way it should be. But it's steel because I'm running the steel Ford Racing gear, and the 2 materials have to be compatible. So when these 2 materials are riding against each other, if you put cast iron with steel, you risk a chance that it's going to gull and wear at an unusual rate. So this will have the same wear rate on both sides, and that gives us a more desirable wear situation. It's not a strength thing in either case, although this gear is actually lighter than most cast iron upper gears, and that's kind of nice. It could be lighter still, but it's plenty light enough. But anyways, so as far as the materials go, make sure you use a steel thrust plate with a steel gear and go from there. Now, the bolts that hold this on are 1/4-20. They are not a particularly big, robust bolt. So we're going to put the thrust plate in place, and the bolts, I put a tiny little drop of red Loctite on them. Yes, I know it's permanent, but just the tiniest little drop is all that's necessary for this application. And I've never had an issue with this, and I've been doing them this way for the better part of 30 years. So we put the bolts in, and these bolts torque to 8 to 10 foot-pounds, or if you're using an inch-pound wrench, that is 96 to 120 inch-pounds. So we're going to split the difference, and we're going to go 108. Snug both of them up first. Click, click. One of the mistakes I see guys make all the time is over tightening the snot out of these little bolts. It's a 1/4-20 bolt. That is not a very robust fastener. It just simply doesn't need a whole lot of torque on it. So we're going to put a little bit of cam lube on the thrust plate. And tap that in just a smidge. There we go. And then we're going to put the gear on. And it's nice and smooth. And that's where the cam needs to be. Now, we'll pull that apart when we're installing the timing chain here in just a minute. So it's time to install the timing chain. Now, this particular camshaft, because of the way it's ground, has to be installed 6 degrees retarded to get me where I want to be. And we're going to talk about this when we degree the camshaft in the next video. But for right now, we're going to just simply install the camshaft. To start, you're going to want to make sure that you have the dowel pin for the camshaft basically straight down, and the keyway on the crankshaft straight up plus a little bit clockwise. That means it's after top dead center, and that's how we're going to align it when we retard the camshaft. So then we want to look at our marks. And our marks on our timing chain set are a little faint, hard to see here. But if you look, there we go. You can see that there is 6R, and 6R is going to line up. The dot on 6R is going to line up to the dot on the cam gear. Now, this is a neat cam gear. Before I install it, I want to show you guys something. On the back, it's got these 2 divots, and those are to carry oil. It also has these 2 grooves, and those are also to help carry oil, but not where you think. These grooves go clear through the center of the gear, and they come out in the front, and they're here to sling oil into the chain to make sure that the chain gets adequate lubrication. So this is a very cool timing chain, and absolutely worth the money when you're going to buy it. So we're going to slide the crank gear on first, and then we're going to bring this guy around, line it up, and if we need to move anything, it's pretty much just a matter of making sure, stick my big bald head in the way of the camera, making sure everything's lined up, and just slide it into place. Now, if you want to be absolutely sure, you can just gently tap that into place, gently tap that, and our crank gear's all the way on. So now the next step is going to be put a drop of thread locker on the cam bolt. Again, just a drop. And this time we're going to use blue So we put our thread locker on, put the bolt in. This is our ARP bolt. And now we have to torque that bolt to spec. All right, this is a 3/8 bolt, and it's going to get torqued to 45 foot-pounds. And to do that, we're going to have to hold the crankshaft. For that, I actually have a couple of different tools. First, if you put one of these engines together, these are really handy to have. Which crank it top dead center. This is a crank nut. It slides on. And then this tool I've had forever. I actually have two of these. This is an old Ford adjustable wrench from a Model A or Model T toolkit. So right there, I have the ability to hold it. The other option I have is I have a crank socket, and I can just use a ratchet. Either works. It's just whatever you have, whatever you prefer. So throw that on there. Our torque wrench is set to 45. Once we hit the click, we're done. Now I'm going to leave that on there because we're going to use that for turning the crankshaft when we start putting the rods and pistons in. All right, just like when we put the pistons in, we got to lubricate everything. And for the lifters, I don't soak them in engine oil. It doesn't really do anything. And I also don't plunge them. It serves little to no purpose. They're going to get filled with oil when you prime the engine, and you're going to check for oil flow at every rocker. So we're going to start by just simply spraying this guy down and get some oil in there. Now, I do have the lifters sitting in a bath of WD-40, and I want to show you guys there is an oil hole in the side of the lifter. Now, on these small block Fords, the oil passage runs more along the top than along the bottom. So we don't have to worry about, like on a Cleveland, where the oil will literally run out of the lifters. We don't have to worry about it like on an LS. But I still, and have always done this, install the lifters with the oil hole up. So it doesn't matter what order you put them in, just install with the oil hole up. And the lifter should have a nice coating of WD-40 on it. And that's honestly adequate. And I should be wearing gloves. Normally, I would wear gloves for this. All right, so that's that side. Now we're going to do the driver's bank. Oil holes up. And I did clean and hone all the lifter bores on this block. This block doesn't actually have a lot of miles on it. So lifters are going in nice. They don't wobble around. We don't have any unnecessary clearance. All right, last one. Okay, now as far as the dog bones go, this is lifter guides. Everybody calls them dog bones because they kind of look like a dog bone. They need to go on and sit down flush. And then, so that I know I built the engine, I always install the front two with up facing the front of the engine and the rear two facing the rear of the engine. And that's just me. And I've done it that way for going on 30 years. When the dog bone doesn't slide over and fall into place, you can use the guide to turn the lifter. So this one is being persnickety. There we go. And last one. Okay. When I did the block prep video, I told you guys I would use a spacer here, the same height as this casting boss, and that would be this washer. It's not going to go anywhere once the bolt is installed and torqued to spec. Another way I know I've installed these is I always put the notch to the back. And that's just me. It doesn't matter. It'll go either way. There is no front or rear on the retainer. It literally doesn't matter. Now, because these bolts are being threaded into holes that I drilled and tapped, and because these are little itty bitty tiny guys and they're not torqued to anything spectacular, 108 inch-pounds is what we're going to torque them to. I put a little bit of red Loctite on them, and that's just me. So put them in, start them, grab your inch-pound wrench. There we go. All right, those are torqued spec, 108 inch-pounds. The retainer's in place, our guide bars are in place, our lifters all have a healthy amount of lubricant. We come back. All right, so everything's torqued to spec. We've got some WD-40 on everything. That'll prevent any kind of corrosion or rust or moisture getting into it. And the next step is going to actually be in video 7, and that'll be installing the cylinder heads and then installing a adjustable push rod and checking the push rod length. All right, so that's camshaft installation for this. And if you go back to my previous video, you'll see that I degreed the camshaft and we're where we need to be as far as piston to valve clearance and the cam timing events being where I actually wanted them. So this whole process is very long and drawn out. If you're trying to build an engine and you're really trying to look for good power, this isn't something you're just gonna go throw parts together in the garage. You might make okay power if you're throwing the parts together and not checking anything, but there's a good chance you're going to have a failure or not have the performance level that you're looking for. And the purpose of this video series is to show you the detail that's required to get the kind of results that so many of you guys are capable of having, but maybe not getting because you're not putting in those last final details and taking those extra steps to measure and check and verify. So I hope this stuff helps you guys, and I hope that this content improves your next build in some way. Okay, I genuinely would love to see more guys building 400, 450, 500 horsepower 302s, 289s, just on the basis that it can totally be done. You don't have to go drop 10 or 12 or $15,000 on a 363 crate engine to have 525 horsepower. That's nonsense. Okay, you can do this stuff for drastically less, build it in your own garage, and have it come together for a hell of a result on a much smaller budget than what you're going to see with most crate engines. It just takes time and patience, and you have to be deliberate. So, anyways, with that, I thank you guys for watching. I genuinely appreciate all of my subscribers, all of my viewers, everybody that comments, and everybody that shares the videos. So, any of those things that you haven't done and you want to, go ahead and do them, and I'll see you in the next video.